The table gives the number of ice cream cones sold by a food vendor on the initial day, which is denoted as T equals 0 when the vendor added ice cream cones to the menu. The vendor sold 14 ice cream cones. 35 days later, when T equals 35, the vendor sold 57 ice cream cones. Day 10, when T equals 10 days after this previous date, which would be T equals 45, the vendor sold 46 ice cream cones. The number of ice cream cones can be sold by a quadratic function where I of T indicates the number of ice cream cones sold on a particular day. That's it, after the initial day. So part A, sub 1. Use the given data to write 3 equations that can be used to find the values for constants A, B, and C for the function I of T. Alright, then the part 2 will actually solve for those. So let's get started. What do we know? Let's do the given information. So let's say I of, on day 0, it is equal to 14 ice cream cones. And we know I of 35 is equivalent to 57. And I of 45, 10 days later, is equivalent to a total of 46 ice cream cones. So we're going to go by this general equation that's provided right here. We can see I have T values and I of T, which equals 14, 57, and 46 for each one. So let's get started. So we're going to say I of, start with the very first one. So I'm going to have 14 is equal to A, and now I'm going to substitute in 0 for T, and 0 for T again. And then I'll do I of 35 equals 57. The same thing, the output value is 57 when T is 35. And lastly, I of 45 equals 46. All right, and so we have 46 equals A, B, and C. Substituting 45 in for the T value. So those are my 3 equations. Let's move on to the second part of A. Now there's multiple ways we can do this, but I want to make this as easy as possible. So what I'm going to do in part B is, I know this is a calculator related problem. I also recognize that I could use the RREF function on my calculator. So I'm going to start by making, by the way, this is called row reduced. Oh, I gotta figure out how to spell the next one. Let me actually press pause and figure out, remember, what does that E stand for? I think it's echelon. It is row reduced echelon form, and so I'm going to use that tool on my calculator. And I wanted to replace the word function with tool. I don't want it to be confused with a mathematical function. So how do we do this? Feel free to run through this with me, and I'll go through it a little bit slower. So this is something that we do learn in Algebra 3-4, and we most likely used it at one point, but not very often, as a tool to solve for variables in a quadratic function. What I'm going to do is I'm going to have an A coefficient, a B coefficient, a C, and then this is going to be the constant on the opposite side. So let's look at the first equation. Okay, so I know 0 squared is 0, so I have 0A. So 0A, I have 0B, 1C, and now I have 14 on the other side. Now I have 35 squared, 35 squared A. I didn't put 0 squared because I knew 0 squared is 0. I have 35B, I have 1C, and 57. Let me move it up. Let's look at the next equation. I have 45 squared A, I have 45B, 1C, and 46. Okay. Now we're going to reset our calculator, 2nd plus 7, 1, 2. And then these are the steps. The first step is we're going to hit second, and then we're going to go down and hit matrix. Second, matrix. And so I'm going to come off to the side and write down these steps as I go. So step 1 is second, and then the matrix key. The next step is we're going to go all the way over to edit and press enter. So edit and enter. Now this is going to be a 3 by 4. So 3 by 4. And now I'm going to plug in values. Okay, so I'm not actually going to put an A, B, or C. I'm just going to put 0, 0, 1, 14. 35 squared, 35, 1, 57. 45 squared, 45, 1, and 46. Okay, so then we're going to get out of the screen, so I'm going to hit second and quit. Second, quit. So I've programmed in this matrix, and now I'm going to use this RREF in order to solve for A, B, and C. And so actually, to be honest with you, I would even write down these steps so they know exactly what you're doing. Okay, then I'm going to hit second matrix. I'm going to go back and hit second matrix on the calculator. So second is that blue key, and then the matrix. Now we need to get to the RREF. This is going to be our tool to solve for us. So to get to it, we're going to go to Math, and we're going to go all the way down to RREF. So RREF, and press enter. And we'll practice this each day just in case you get something like this where I will put up 3 different ordered pairs that we can find from a quadratic function, and you'll see that you can do this literally. If we practice a couple each day, you'll be able to do this in under a minute. Now this is going to be the tool to solve this equation, right? And I have a matrix here, so I need to go back and figure out where is that matrix. So if I go second matrix, we can see this is the programmed in matrix. And then I'm going to press enter, and I believe I'm going to press enter 3 times. Let's check. There's enter once and enter twice. Now, how do I get this? This is the first value, the second value, and the third value. If we look back in the directions, it says find the values of A, B, and C as decimal approximations. So if I move this up just a little bit more, I can say that A is approximately negative 0.052. B is approximately 3.0. Okay, now this would be 0.39, but this rounds up, so 40. C is exactly 14. Here you can see we had to make an approximation. This is going to be an exact value. Let's move on to part B. Okay, so we're going to go ahead here, and I have taken my A, B, and C. Remember, A and B I did round to the nearest thousands, and now I've been asked to find the average rate of change from, let's look back here, from T equals 35 to T equals 45. So I'm going to write this out. So T equals 45 minus T equals 35 over 45 minus 35. So I've taken this general equations. Now that I've solved for A and B, I've plugged it in. We're going to come up here, and there's 2 ways I can do this. One way is I can actually plug this in. So negative 0.052 T squared. And then we are going to do plus 3.040 T plus 14. Whoa, what just happened here? 0.0 x plus 14. Okay, so let's make sure we go out far enough here. Let's go out to like 60. Let's do a zoom fit. So I want to figure out when I substitute in 45, what's the output? So second trace value, when I plug in 45, I have 45.5 minus, now when I substitute in a value of 35, I have 56.7. On the bottom, I know 45 minus 10, or 45 minus 35 is 10. And we have an answer of approximately, I said approximately because I know that I rounded here, so approximately negative 1.12. And now I need to actually label what does this mean. So this is talking about the number of ice cream cones sold per day. Ice cream cones, let's see, on average, the number of ice cream cones sold per day between day 35 to 45. Make sure to be specific within the context of. Okay, let's look at the second part. So the second part of this problem says, and let me find the exact question for it. Give me 1 second. I misplaced it. Oh well, I will find it. Alright, here it is. The second part says use the average rate of change from part A to estimate the number of ice creams sold on day 40. So we found the average rate of change on the secant. So if I look here, this is my original model. This is I of t. This is I of t that creates this parabola from the quadratic function. And then in part A, we found the average rate of change specifically from 35 to 45. So the average rate of change, or the slope of the secant line from 35 to 45. Now, part B, if I come in here, part B says use the average rate of change, which I have as negative 1.12, from this previous step to estimate the number of ice cream sold on 40. So we're looking at, when I go to the secant line, what would be the t value? And then it says show me how to reach this answer. Now, this is a calculator-related problem. And so what I'm going to demonstrate is I'm going to demonstrate how to use a linear regression model. But we must say that's what we're doing. So I use a linear regression model to find the average, to find the equation of the secant line between t equals 35 to t equals 45. So I'm going to put down what I know. I know that at 35, I have an output value. So let me put in this original equation. So let me go up to this original equation and type this in. Now, if somebody rounded slightly different than we did, then their answer is going to be just slightly off, right? Depends on how that rounding goes. So let's come up to this windows and let's go all the way out to, let's say 60, and let's take a look at what this looks like. So this model's in any given day. After the initial day, it tells us what is going to be the output value, or the number of ice cream sold on a particular day. Now, we want to go to 35. Now, 35, we have 56.7. By the way, we can see that right up here as well. So on 35, we have 56.7 using my model. And on day 45, look at, we can see we have 45.5. And I want to know from here to here, so from 35 to 45, if I drew the straight line right here, I want to know what would be the equation of that line. So how can I use the calculator? Well, it's going to be a straight line, so it's going to be linear. And so I'm going to use the linear regression model, and that's what I'm telling the AP reader. A linear regression model is used to find the equation of a secant line from t equals 35 to t equals 45, and I actually show those points. So I'm going to come up to stats and press enter. And I'm going to go 35 corresponds with 56.7. 35 enter corresponds with 56.7. Gosh, let's try this again. And I have 45 corresponds to 45.5. Okay, now if I go to stats and I go to calculate, we're going to go all the way down to linear regression. I'm just going to press enter all the way through. So I've pressed enter all the way through, and I can see that this is my slope, the value that's stuck with the x. So I have negative 1.12 plus 95.9. In fact, you know what, I think there'd be less problems with that if we did it like this. and we can see the value stuck with the A is going to be right here. So it's negative 1.12x plus 95.9. Because it's quiz. Alright, so what I need to do right now is I'm going to come back here and I want to find from the secant line from t equals 35 to t equals 45, I want to find what is the value when t is 40 on that secant line. So what I can do is I can take this and I can plug this in. So if I come up here, I can come back and do, and there, you could just type it in if that helps you. Maybe that's less operations to remember, especially considering this is a pretty easy equation. So I want to know on this red line, I want to know exactly what is. Thank you for your patience while I have students testing right now in front of me. So I'm looking at the red line, and I want to know when I go to 40, what is the output value for the red line? So I'm going to go second trace. Oops, sorry, I'm going to go up to table, actually. I think that'll be even easier. And I'm going to go all the way down to 40. And when I get to 40, I want to look at that red line. Okay, so I'm looking right over here. And so my output value from this is when I substitute, or you could just plug 40 right into this if you didn't want to graph it. I'll demonstrate that as well. Is 51.1. So notice that if I even just came right over here, if I came right to here and plugged in negative 1.12 times 40 plus 95.9, I get the exact same answer, 51.1. Okay, so let's look at the third part of B. And the third part of B says to compare the estimates from part B. So compare the estimate when t equals 40 for the secant line to when t equals 40 for the actual function that was provided for us where we identified the value of a, b, and c. So we can compare the function to the secant line specifically between t equals 35 to t equals 45. Well, I can see that if we're looking right up here and I zoom out, I can see that I of t is a quadratic function. It has a negative leading coefficient. I specifically say what that is. That's the a value, the leading coefficient. Because of that, it's going to open up downwards. Whenever we're looking at the quadratic and a is negative, it opens down. Vice versa, if a was positive, it would open up. So because it opens down, it's also considered to be concave down on the entire domain. So this entire domain of this function will look like this. The second thing is the secant line from t equals 35 to t equals 45 is below the quadratic function from t equals 35 to t equals 45. We do want to say specifically where is it below, because if you can see that here, it will eventually be above. So specifically from this interval, you could also write that interval as 35 to 45. The secant line is below, and so the secant line represents output values when t equals 35 to t equals 45. So then we can make the assumption that the estimation on day 40 will be lower on the secant line than it will be on the function I of t. Please don't hesitate to expand, giving as much information as you know as you compare these two functions. The last part of this long problem is explain how the range of the values should be limited. The range and not the domain. So when I first saw this, I actually called David over seconds ago, and then I reread it before I got there and saw that it said range. Explain how the range of the values for part C of the function I of t should be limited within the context. So we're wondering how low does it go up to how high it goes. So I'm looking for using graphing calculator to determine the maximum value. However, we have to tell the reader exactly what we are doing, so they don't just see an answer and think, hey, did they copy, did they guess? They need to know exactly what you're doing. All right, so when I look at this, and now I'm going to show what the range could be. Okay, the range can go as low as 0, so this range, so the output value can go as low as 0. This is our output or our y values, right? This is like our y values. But within the context of the problem, we say I of t, so the number of ice creams sold on a particular day. This is important to have the right notation. And with my range, it goes up as high as 58.431. 58.431. So when we think about this, within the context of the problem, T really represents days. So our time in days would run from, this is days and this is ice cream. Oh, I got it mixed up again. This is ice cream. So number of ice cream cones sold on a particular day should be limited from 0 to, and whether you leave it like this or write 59. I say that because that's a little bit more than 58. If we just say 58, and we're knowing that this is ice cream cone sold, you can't sell 58.4 ice creams, right? You're going to sell 58 or 59. And then this is explaining within the context of the problem.